so I'm going to go over one question on each circle graph from your homework. And when you are reading a circle graph, as you can see on this first page, they can put the data in the graph 3 different ways. They can either represent the data as a percent, like they did in this first graph, the percent of time Ted spent doing different activities. The middle graph, they have represented the data as a fraction, and this is from your homework, the fraction of kids who voted for each different actor. Or the third one, the data is represented as the actual number of people who vacationed in different spots during their summer off. So if you remember in class, we had a handout on circle graph notes. We went over some of the last page, but we didn't take a look at this first page. And on this slide, you can see that it says circle graphs compare part of something to a whole. And then the 2 things that you might need help with, which I put a box around and drawn arrows to, is calculating the percentage or calculating the central angle. This last one is something you guys are probably not familiar with. This can also be referred to as the degree, and that is going to actually be the little section of the circle graph. If you were to measure it with a protractor and be as exact as possible, how many degrees would this angle be for that one section of the circle graph that you're talking about? Okay, so if you need to do that, which it's going to ask you to, you take the amount of that one particular piece. Let's say maybe the people who went to Europe divided by the total people who went on vacation, and then you multiply it by 360, and we use 360 because that's how many degrees one complete circle is. If you're someone who rides a skateboard or rides a wakeboard and they said, hey, I did a 360, that means they turned completely around. Okay, you can also see some information down here at the bottom. That's on the same page in your notes. If you need to read that for help, you can. Okay, so now we're going to look at the homework. On the very first page, questions 1 through 5 are talking about this graph. And in number 1, there's really not a question to answer. It just tells you how many total kids there were who were voting or represented in this circle graph. So we need to make sure that we are using this number 30. 30 is going to be our total. And in question 2, it says, how many voted for Sean Connery? Well, if you look at the puzzle or the circle graph, Sean Connery is represented by this piece, which is 1/5 of the whole thing. So if I want to know how many real people voted for Sean Connery, what I'm going to do is I'm going to take the fraction of the circle that's Sean Connery. I am going to make it equal to the total amount of people who voted. And then on top, I don't know how many people voted for Sean Connery. Now, it is just 2 fractions or 2 ratios, and I want them to be equal. If you look at this, I could have a relationship going sideways. I can turn 5 into 30. And I would do that just by increasing it 6 times. So you probably remember from 6th grade or elementary school, when you're making equal fractions, whatever you do to the bottom, you must do to the top. So if I did 5 times 6 to get 30, I would also need to do 1 times 6 to get the actual number of people who voted for Sean Connery. So once you do that, 1 times 6 is 6. So in question 2, you want to fill that in with 6. Now, question 3, 4, and 5 is not just asking for one specific person, so you're going to need to read very carefully. Question 3, it says how many people did not vote. Question 4 said how many more people voted. That's a clue for subtraction. And then question 5 said how many people voted all together for 2 different actors. So you're going to have to add those sections together. If you move down to the next group, questions 6 through 10, still on the same page, but now a new circle graph. This one is representing the pieces by actual number of students who vacationed in different places. So again, the first question, number 6, really doesn't ask you to do anything. It just tells you what the total number of people were who are represented in this graph. So we're going to be using 60. And every one of these questions asks what fraction. What fraction of people, what fraction of people. But they're asking you to look at different things. So if you look at question 7, what fraction of people vacationed in another state? So if you look over on the sides, they have labeled all the sections outside the graph with the category. So another state is actually this section. 18 people went in another state. If I know 60 people were there in all, and 18 of them vacationed in another state, then basically my fraction is 18 out of 60. But you should always represent your fractions in simplest form, so we need to reduce this. 18 and 60 have several factors that they share in common, but the biggest one is 6. So if you divide them both by the greatest common factor, you will automatically get the most reduced fraction possible. So 18 divided by 6 is 3, and 60 divided by 6 is 10. So I would want to put on question 7 that 3/10 of the people vacationed in another state. Now, just like in the first section of graphs, number 8, 9, and 10 do not just ask you for one specific thing, so you're going to have to read carefully. Number 8 asks you what fraction of people vacationed in Canada, Mexico, or Europe. So that's combining two sections. Number 9 is saying what fraction of people did not stay at home. And in question 10, it says what fraction of people vacationed in their state or another state. So 8 and 10 are combining two sections of the graph. Question number 11. Most of you can probably get the fraction column. Probably some of you can get the percent column, but the degrees column, the last one, is going to be tricky for lots of people. So before we can even get started with the fraction, the percent, or the decimal, we need to know what is the total number of people represented in this graph. So this is question 11. And they took a survey on people's favorite flavors of ice cream. So I am going to do mango on this slide for you. I'm going to find the fraction of people who picked mango, the percent of people who picked mango, and the degrees that's going to represent this section of the circle graph. And I want to know it exactly, not guessing. So if you add up all of the people, 8 plus 16 plus 6 plus 12 plus 6. Please be careful. They have not lined these numbers up accurately. They have some 1's digits lined up with 10's digits. So you need to add those up carefully. When I added them up, I got 48 for my total. The fraction should be 1 whole always. The percent should be 100% always. And the degrees should be 360 degrees. Okay, and then the fraction can be 1 out of 1, or if everything had a denominator of 48, then it would be 48 out of 48. Okay, so the first one we're going to do is mango, and I want to know the fraction of people who picked mango. So I am simply going to take the number of people who liked mango, 8, the total number of people represented in the graph, 48, and then again, I want to represent this fraction in the most simplified form. So 8 and 48, the greatest common factor they have is 8. So I'm going to divide them both by 8, and that should be 1/6. Okay, so my fraction is 1/6. Now, to calculate the percent, if you look back on your notes page or on the slide towards the front of this video, it says you need the amount divided by the total. So for us, that's either going to be 8 divided by 48, or you can use the simplified version of 1 divided by 6, and then you need to multiply by 100 because percents are always out of 100. So I'm just going to do the simple version. I'm going to say 1 divided by 6. Okay, 6 can't go into 1, so I know it's definitely going to be 1.00. I'm going to go ahead and put 0 point because I know it won't work. 6 can go into 10 one time. I'm going to subtract 6. I get 4. Bring down the next digit. 6 can go into 40 6 times. That's 36. When I subtract, I get 4. If I bring down another 0, you might notice that this 40 is now being repeated again down here. So my next digit is still going to repeat a 6. So I'm going to put a line above that. The last step in getting your percentage is multiply that number times 100. And you can mentally multiply things by 100 in your brain. All you need to do is move the decimal over 2 spots. And remember, these 6's we're going to keep repeating. So now my percentage should be 16.6 repeating percent. 16.6, and the 6's are going to repeat. Okay, the last thing we need to find is the degrees. So on your notes handout, it said to get the degrees or the angle, you need to take the amount divided by the total, which we've already done that. The amount divided by the total should be 0.166 repeating, and then multiply it by 360 because that's how many degrees a full circle is. So I am going to do 0.166, and even though that's repeating, I'm just going to say 0.166. I'm going to multiply that by 360, and you guys can double check me on this, but when I worked it out, I got 59.76. Now, because this is a repeating decimal, it's not going to be exactly 59.77 degrees, so I'm going to put the sign that means about, 2 wavy equal lines, and then I'm going to put 59.76 and then the degree sign. Okay, that's how you'll do every one of these rows. You might notice that chocolate is twice as much as mango. So if I were you, I probably wouldn't do all the work of figuring out each one of these categories separately. I would probably just double all of the mango values, and then that should give you chocolate. If you notice the other categories, crunch and pineapple are both 6. So when you calculate crunch, just copy it for pineapple. And then, oh my gosh, vanilla is twice as much as crunch and pineapple. So you really only need to calculate mango and vanilla and then double those values, or mango and crunch or pineapple, and then double it to get vanilla and chocolate. Okay? The next page was just the same. It was circle graphs for voting for favorite teacher of the year. There's no circle graph to look at, so all you need to do is complete that table just like I did. Okay, now on the bar graphs. The next few pages are about bar graphs, which you guys should be really familiar with. I'm sure you use them in elementary school all the time because they're a great way to represent data. However, on the x-axis, those labels were not very clear. So, the first graph, which is up here in the top right-hand corner, the first bar is for Carl, the second bar is for Hank, the next bar is for Pam, and the last bar is for Tim. So, if you couldn't read those are the 4 people's names that are represented by books they purchased. The same page, this graph on the left side of your page, says tourists visited in the thousands. So you can go to Delhi, Dubai, I'm not sure how to pronounce the J one, or Kabul. I know they use those words down in the questions underneath the graph, but if you're having trouble figuring it out, those are the 4 cities people could visit. And then when you flip to the other page, at the bottom of it, it's customer complaints, and then there are 4 possible stores, I guess, or 4 parts of a company that could get customer complaints. And I know these are also listed in the questions under the graph, but if you're having trouble reading them, here are the 4 categories for those bars. So on the very back page, it says in the directions, create a bar graph. So please make sure you're creating a bar graph. I have also labeled the axis for you. The x-axis